Hi, welcome back to my channel Maths with Armin. In this grade 12 mathematics video on differential calculus, I want to show you how we can determine the first derivative of a function using first principles. If you have not done so yet, please subscribe to my channel Maths with Armin. Then we're going to look at the first derivative using first principles, and I want to briefly just explain to you the definition of a first derivative and the concept of a first derivative. F prime x is equal to the limit as h approaches 0 of fx plus h minus fx, everything divided by h. Then we're going to look at four functions, and let's look at the defining equations for the first for these four functions. First one is the linear, fx equal to ax plus b. Then we're going to look at the quadratic, gx equal to ax squared plus bx plus c. And then we're going to have a cubic one, kx equal to ax cubed. And then we're going to have an hyperbolic one, a very simple one, a over x. And as usual with all my videos, there'll be a short exercise worksheet for you. Let's look at the gradient of the secant of a curve of a function first. Let's consider a function f, which is represented here by the yellow curve there. And then let's choose 2 points on the curve, point A and point B. Point A's coordinates would be xa, ya, and point B would be xb, yb. Now let's draw a line through A and B, and this line here, as you can see in this blue color, that is the secant. It cuts the curve at 2 points A and B. Now the coordinates of A, if I look at this here, I can also write the coordinates of A as x, and the x corresponds with the y value, which is fx. The same with B. I can have x plus h because it's more than, see that's x, it's more than x plus h. So the corresponding y values function notation would be fx plus h. Now let's just get the formula for the gradient of the secant AB. So the gradient there, what is the gradient? That's correct, it's the change in y over the change in x, which you can also write what we know from analytical geometry as y2 minus y1 over x2 minus x1. So the gradient of the secant of AB would be the y2, which is yb minus ya, and then corresponding x2, which is the xb minus the xa, right? So that's the gradient of the secant there. It's the change in the y over the change in the x. Now, what is yb? Yb we can write as, that's correct, it's fx plus h minus the ya, which is fx. And then the xb is my x plus h, and the xa is my x there. So you can see there, this x and the negative x gives you a 0, and this simplifies to fx plus h minus fx over h. Now this quotient here, this fraction here, this quotient here is also known as Newton's quotient, after the mathematician Sir Isaac Newton. So that's also known as Newton's quotient. So fx plus h minus fx over h is also written in this form. It's also known as Newton's quotient. So the gradient of a secant, there we have it as fx plus h minus fx over h. And it's also known as, we can also refer to this as the average rate of change. So finding the average rate of change is the same as working out Newton's quotient. It's the same as finding the gradient of a secant or the gradient of a chord. To determine the gradient of a tangent of a curve of a function at a specific point. Let's just start again with our secant. There we've got the secant AB, and we have already previously determined the gradient of the secant. there's the gradient of the secant, which is Newton's quotient, fx plus h minus fx over h. Now, if we take the secant AB and we look at another option there, can you see that secant there is now, the chord is shorter from A to B, that's another point B. So if, let's say, this was x and that is x plus h, so the B there, the h should be smaller. So let's say the h was 1, then this h here with this AB there, this other AB, this would be 0,9. Similarly, if I take another one here, can you see that I've got another chord? The chord is shorter and the h is then smaller, so that was 0,9. Maybe the h here would be 0,7. Let's take another, and here we've got 2 more. So this h here would be 0,2, and maybe that is 0,5, and that's 0,7, and the other one there is 0,9. So if I keep on doing that until the h gets smaller and smaller and smaller, eventually I end up with this line. And what is that line? That is the tangent, right? And there you can see we get the tangent as the h approaches 0. So now we don't have a secant anymore. That is now going to become, there I've got my tangent. So let's get the gradient of this tangent. How did I get that? The chord became smaller and smaller and smaller until eventually h approaches 0. So when h approaches 0, then I don't have a secant anymore, then I have a tangent. That in this way approaches 0, we can say it's the limit value as h approaches 0 of Newton's quotient, or the limit value there of the gradient of the secant. Now this expression, the limit as h approaches 0 of fx plus h minus fx over h, we have a symbol for that, and that we have there, and this we read as f prime x. So f prime x is the limit as h approaches 0 of fx plus h minus fx over h. And this here is how the formula we'll use to determine the gradient of a tangent. Now this f prime x, we also refer to it as the derivative, more specifically the first derivative. So the first derivative of function f will be f prime x is limit as h approaches 0 of fx plus h minus fx over h. Now the derivative is also known as the instantaneous rate of change. So gradient of a tangent, derivative, instantaneous rate of change, they all mean exactly the same. Now we want to determine the gradient of a tangent of a curve of a function at a point. So let's go back to our gradient of the secant. Let's look at there we've got a secant AB, and the gradient of the secant, as we've previously seen, is fx plus h minus fx over h. There we have the gradient of the secant. Now, if I take that chord AB, I want to draw another chord, but the chord must be shorter. So if I have that one, see there I've got another chord. That chord is now shorter. So let's say the distance from x to x plus h was 1. Now for the shorter chord, that h value will be less. So if that h value was 1, the h value for this chord now would be, let's say, 0,9. Also, let's look at another case there. There I've got another chord, shorter again. You can see that one is shorter. So this h value will be smaller than that 0,9. Let's say it's about 0,7. And we can keep on doing that. There I've got 2 more. So maybe there the h is 0,2, maybe there's the h 0,5, 0,7, and I can keep on making the chord smaller and smaller and smaller until eventually I end up with this. And what is this line here? That's correct. That will represent the tangent. So let's look at the tangent now. There I've got the tangent. So it's actually the chord becoming smaller and smaller and smaller. In other words, the h getting smaller and smaller until the h, that's correct, the h approaches 0. Now we can get the gradient of a tangent. As h approaches 0, We can write it as the limit as h approaches 0 of Newton's quotient, and this here is the gradient of a tangent. Now we have a symbol that represents that, and there we have got the symbol here, and this we read as f prime x. So f prime of x means the gradient of a tangent. So f prime x is the limit as h approaches 0 of the gradient of the secant, or fx plus h minus fx over h. Now this f prime x, we also refer to it as the derivative, more specifically the first derivative. So the first derivative is f prime x, the first derivative is gradient of a tangent. This is also known as the instantaneous rate of change. So instantaneous rate of change, derivative and gradient of a tangent are all the same. They all mean f prime x, which is limit as h approaches 0 of fx plus h minus fx over h. Now see that we can define the first derivative as follows. The first derivative of a function at a point on the curve is equal to the gradient of a tangent to the curve at that point. So the first derivative is equal to the gradient of a tangent. This gives us a formula. F prime x is equal to the limit as h approaches 0 of fx plus h minus fx over h. Look at 4 examples. One linear equation, one quadratic equation, one cubic equation, and one hyperbolic equation there, as prescribed for CAPS Mathematics, grade 12. Let's look at the first example, how to determine the derivative using first principles. Example 1. Fx equal to 2x plus 3, determine the first derivative using first principles. What do we mean by first principles? That is, we must apply the definition, and this is the definition, and this definition is provided on the information sheet. So let's start off. We want to find the limit as h approaches 0. Let's put that division line over h. That's always over h. That's always h approaches 0. X plus h, so I must substitute x plus h in there. So that gives me 2x plus h plus 3. The x is replaced by x plus h. Subtract, and it's best here to enclose that in brackets. Now we expand by removing the brackets, and you notice the 2x and the negative 2x gives you a 0. 3 and negative 3 gives me a 0. And then I end with a simplified expression. However, h is not 0, so I'm allowed to cancel the h there. And that gives me limit of 2. This is the limit of a constant. So that it's constant, it just remains a constant. What is the constant? 2, irrespective of what h is. So that still remains 2. Let's see what did we obtain here. This is the first derivative, and what is the first derivative here? What's this derivative? This derivative here is the gradient of a tangent, and I want to know the gradient of a straight line. So what's the gradient of a straight line? The gradient of a straight line, there's it, it's given in the equation there. That 2 is the gradient. So the gradient here is 2, therefore I'm not surprised to get the answer 2 here. This is a constant value. The gradient of a constant is a horizontal line, and the gradient of a horizontal line is, that's right, is 0. So this one is just 2. So let's take another straight line. So what will the gradient of this straight line be? 5. Therefore the first derivative is 5. What's the gradient of the straight line? 12. Therefore it is 12. What's the gradient of the straight line? Negative 6. So that's negative 6. What's the gradient of this straight line? That's right, there's a 1 there. The gradient is 1, right? So actually this part here, the constant part is always 0, right? The gradient of a constant is always equal to. Let's look at the second example. fx is equal to x squared minus x plus 2. There we have a quadratic expression. We want to determine the first derivative using first principles. So we start with the definition. As you can see there's the definition. The definition is given on the information sheet. So let's write down limit. Draw a line straight through over h as h approaches 0. H always approaches 0. X plus h, so we must replace the x with the x plus h, and that x with the x plus h, that gives us that. Then we must subtract fx, or subtract. Let's enclose the fx in brackets. We then expand. We expand that, x plus 8, be careful with this. Expand that, and that's what we get after expanding. Some of the terms can neutralize each other, as you can see there. Negative x with a positive x, and a positive 2 with a negative 2. That gives us this expression here. Because h is not 0, it approaches 0, we can divide by h, and then we end up with that. This is now a polynomial. When you have a polynomial, the limit value of a polynomial is the function value. So we can just substitute h is equal to 0. We simplify that, and we get that expression. Just analyze it. You see, this is a constant, and the gradient of a constant would be a 0. This here is a negative x, so the gradient of that part there is negative 1. This one here is x squared, and its gradient is 2x. Right? Let's take something similar. I've got x squared plus 4x, so this one here, if we go through this process, what will that be? 2x plus 4. And this one, 2x plus 0. And this one, that's right, negative 2x plus 3. And the last one, negative 2x plus 0. So from this, we can already see we can find a short way of determining the derivative. Let's take another one. You're also required to find the derivative of a cube, x cubed. So let's use our definition. We then get the limit of h approaching 0, divide, and there we have divide by h. X plus h, you replace the x with the x plus h, that gives us x plus h cubed minus x cubed. We now have to expand that. You can either multiply those brackets out, or you should know x plus h squared is x squared plus 2xh plus h squared. Similarly, x cubed is x cubed, x plus h cubed is x cubed plus 3x squared h plus 3xh squared plus h cubed, and then we subtract that. There are some terms that can cancel each other out, and I end up with that. H is not 0, so I can divide by h. That gives me this expression, which is a polynomial. Therefore, I can find the function value. So h becomes 0, that becomes 0, that becomes 0, and I end up with 3x squared. Now let's just look at this here. X cubed becomes 3x squared. So if I have x to the 5th using the same thing, that will become 5x4. X to the 7 will become 7x6. X to the 9 becomes 9x to the 8. X to the 11 becomes 11x to the 10. Right? So from this, we can already see we can find a rule for first principle, assist us in determining a rule for power. We should also be able to find the derivative of a rational function divided by 2 over x or 3 over x or negative 4 over x. And using first principles, that means we use our definition. We now need to substitute. So let's put x plus h in the x. So that will be 2 over x plus h. Subtract, so subtract 2 over x. What do we need to simplify fractions? That's correct. Find the lowest common denominator. The numerator will be 2 times x minus 2 times x plus h. Let's expand that. See there, we've expanded. Now instead of writing over h, I've now written that over h as times 1 over h. Right? It's much easier there. We can simplify. You can see the 2 x's neutralize each other. This h is not 0, so I can divide by that h, and that h. And I then end up with a simplified expression there. Because the denominator is not 0, I can substitute 0 and I end up with that. X times x is x squared, and there's the derivative of 2 over x. Let's just look at the given expression and the derivative. A positive 2 became a negative 2. Divide by x became divided by x squared. Let's see whether we can generalize here. Negative 5 over x will become positive 5 over x squared. 3 over x squared becomes negative 3 over x3. 4 becomes negative 4 over x4. Negative 2 becomes positive 2 over x. Now it's your turn. Let's look at a exercise worksheet. In this exercise worksheet, you are given 5 questions here to determine the first derivative using first principles. The first one being a constant, the second a linear, the third a quadratic, the fourth one a cubic, and the last one a hyperbolic. At the end of the video, you will be able to see the detailed solutions for these 5 problems. I do hope that this video has helped you to understand the concept of first principles and how to use first principles to find the first derivative. I have also prepared many other videos on mathematics topics, grade 12 CAPS mathematics topics. Please, if you have not done so yet, please subscribe to my channel, Maths with Armien. Also, please share it with other learners as well. Maths with Armien. Thank you. The solutions to the exercise worksheet. You can compare your answers. I've prepared detailed solutions to each of the questions. Question number A. Find the derivative of fx equal to 5. Here's the solution. Number B. Fx is equal to 3x minus 1. Find the first derivative. Here's the detailed solution. C. Fx is equal to negative x squared plus 2x plus 3. Here's the detailed solution of finding the first derivative from first principles. Fx is equal to 2x cubed. Use first principles to find the derivative. Here's the detailed solution. Fx equal to negative 3 over x. Find the first derivative using first principles. Here's the detailed solution. This video has helped you with the understanding of determining the first derivative using first principles. I've also prepared many other videos on grade 12 mathematics topics. If you go to my channel, Maths with Armien, you'll find all of them. And please, if you have not done so before, please subscribe to my channel. And also don't forget to share with your friends.